Okay, so I'm going to explain the Moody diagram and what is used for. It is used for the calculation of the friction factor of a fluid of a flow. For this, we need to know the relative pipe roughness, which is given by the roughness divided the diameter, and the Reynolds numbers, which can be calculated with the velocity and the diameter. We need to clarify that the velocity and the diameters are given by meters per second and meters respectively. So first of all, we have the part of the laminar flow, which is this one over here. And for this part, the only information we need to obtain the friction factor is going to be the Reynolds number. Then we have the transition region, which is this part over here. And in this part, we are going to start using the roughness of the pipe. And finally, the turbulent area, which is all this part over here, in which we are going to take into consideration the relative pipe roughness and the Reynolds numbers to obtain the friction factor. Continuing with this, we can obtain this number by converging like the first part, which is going to be knowing the diameter of the pipe, and then we can know the relative pipe roughness if we do know the roughness, which is given by this expression over here. And the relative pipe roughness is going to be given by the roughness divided the diameter. And once we have this, we can obtain, for example, we have a relative pipe roughness of 0.002. We're going to trace a line over here until we arrive to the part which we calculated for the Reynolds number. So for example, if we obtained a Reynolds number of 10 to the 5, so we are going to trace this line of the, following the curve of the relative pipe roughness until the 10 to the 5. And we are going to trace the same as over here, the same line till the Reynolds number, which is going to be here. And then we have to draw a horizontal line until the friction factor, starting from the part where these both numbers converge with this point. And for example, if we trace the line, we are going to obtain a friction factor of approximately 0.025. And that's the way we calculate the friction factor with the Moody diagram. After this, I am going to explain the problem 8.5 of our book, which is here. May I erase these things? And for this problem, they are asking us to obtain the flow rate only given the head loss and in an air duct, which are given in this expression. So for this problem, they are not giving us the diameter, neither the velocity, which are the two numbers we need to obtain the Reynolds numbers. But we can also obtain the Reynolds number with some iterations using, first calculating the average velocity through the pipe. We are going to establish a guess of a friction factor, which for this example, we use 0.04. And what we are going to do, the number is over here, and this is the average velocity through the pipe formula. Here is the letter that stands for the friction factor. Well, I'm not going to write that all. And this is the guess we made, that is 0.04 for this example. So what we are going to do is we are going to start iterating the friction factor guess until we converge this number with the correct friction factor given the iterations. For this example, we found that the iteration converged when the four numbers were, One moment, please. One moment, please. I'm going to erase this drawings. Okay, so here we can see that the iterations of when the 4 digits is the iteration convert with 4 digits when there were 4 iterations. And given this, we can calculate with the Swamy-Jane formula the flow rate. We are going to substitute the values we calculated previously and in the formula, and with this we can obtain the flow rate, which is going to be, for this example, 0.24 cubic meters per second. And that's all.